Hi there again. Sick of me yet? Sorry. Okay, so this is lesson 6.2, perpendicular lines and angle bisectors. Perpendicular lines, if you remember, they meet at right angles, okay? Perpendicular lines form right angles. Okay, a perpendicular bisector cut into equal pieces of a line segment is a line that is perpendicular to the segment and divides it in half. Now this I've mentioned before, but we're going to focus on it a lot for this section. Any point on this perpendicular bisector is equally distant from points A and B. So any point I could draw on this perpendicular bisector, okay, Percy the perpendicular bisector, any point on him is equally distant from A and B. Okay, keep that in mind. Okay, we want to prove that PA is congruent to PB, or they're equal, same difference. Okay, we're given PM is Percy the perpendicular bisector of AB. What does that tell me? Okay, perpendicular, I have 90-degree angles. We got that. Bisector cuts it into two equal halves. Now you notice two triangles, yes? Which side is this in? Okay, both sides, yes. Let's look at that. Let me fix this for a second. Whee! Okay, so it's in both triangles. Yes, yes, yes. PM. Thank goodness it's not PMS. It's in both triangles. Okay, so what do I know? I know that I have two congruent triangles by side, included angle, side, side, included angle, side. So once I know that the triangles are congruent, every other matching part of each triangle is also congruent. All right, so we just basically proved that this guy, PA, is equal to PB using corresponding parts of congruent triangles are congruent. All right, here it is formally written up. There it was. There we go. Okay, PM is the perpendicular bisector of AB. That was given to us. Then we're going to go where that takes us. PMA and PMB are right angles. Perpendicular lines form right angles. Okay, they're congruent. All right angles are congruent. So we have a pair of congruent angles there. AM equals MB. Definition of a bisector. PM equals itself. That's the reflexive property. We have the two triangles congruent by side angle side, and therefore every other matching part is congruent by corresponding parts of congruent triangles are congruent. And all you have to write is the initials, because writing that out will take you the whole regions if you're taking it. All right, so the perpendicular bisector theorem. If a point is the same distance away, okay, this is the converse. If a point is the same distance away from a segment's endpoints, then it happens to be on the perpendicular bisector of that segment. Okay, so point P is the same distance away from A and B, therefore it is on the perpendicular bisector M of this triangle. All right, what is the length of IB? Yeah, IB. Okay, so what do I know? Okay, it's marked that this is perpendicular and that these guys are equal, so this is the perpendicular bisector. So I have side included angle side, side included angle side. I have that the triangles are congruent. So therefore I know that this guy is going to be equal to this guy. We good with that? So let's set them equal to each other and solve. We want to solve for A. So we have 2A plus 7 is going to equal this mess. Okay, then we're going to distribute. Okay, because we love distributing. We always want to share. The sharing is caring. Okay, so we have 2A plus 7 equals 4A minus 6. Subtract 2A. We're left with 7 equals 2A minus 6. Because 4A minus 2A. Hey, I got 2 A's left. Okay, add 6 to both sides. 2A equals 13. divide both sides by 2, a equals 6.5. Now, did I answer the question? I did not. I want to know the length of JB or IB. What is it? I don't know, whatever it is. I want to know the length of this guy. All right, so to do that, I have to plug it in. And I took the liberty of plugging it in for us. Okay, 2 times 6.5 plus 7. 6.5 times 2 is 13. We all agree. 13 plus 7 is 20. And just to prove that it works, I plugged it into the other one as well. 2 times 13 minus 3. We all agree 13 minus 3 is 10. 2 times 10 is 20. So they're exactly the same. Go us, go us. It's a birthday. Okay, let's go. And here it is again. And you notice the same thing, but they didn't do the check. I like to double check. All right. We want to prove that triangle XYZ is isosceles. Let's see what they gave us. They gave us perpendicular. They gave us, these guys are congruent, so it's the perpendicular bisector. Okay, and we know that this guy is in both triangles by the reflexive property. Therefore, this guy is equal to this guy by CPCTC. And so we know that it's an isosceles triangle because an isosceles triangle has at least 2 congruent sides. It used to be exactly 2, but they changed it, making me crazy. Okay, we have perpendicular bisector. That's given from the diagram. Okay, since y is on the perpendicular bisector, it is equally distant from the point at the top there. So they're equal. So since there are 2 equal lines there, 2 equal sides, 2 congruent sides, the triangle is isosceles. And pause the video, stop and take a break whenever you need. All right, I'm going to pause for a couple seconds. I love this problem, but I want you to take a breath. I'm going to pause myself. You can pause the video as well and then come back in a couple of seconds. Okay, I drew in some stuff for us. An acrobat is secured by 2 7-meter ropes. Never find me like that. Where am I? She's attached by 2 7-meter ropes, which are attached to the ends of a 4-meter bar. I don't think so. What is his vertical distance from the bar to the nearest 10th? Now, straight, like you know that this is a straight line. Therefore, perpendicular. And believe it or not, it's also the perpendicular bisector. So now, we need to know this length. I'm going to call it x. Okay? Oh, that's a lovely x, but we'll get over it. Now, if you notice, I have a right triangle. And each of these sides, by the way, is 2. So I have 2 and 2. And if you remember, I told you to think of something whenever you hear right triangle. Think of a squared plus b squared equals c squared. That's what we're going to do here. We have a. We don't have b. We do have c. Now, you can do this in your calculator all in one calculation, but I'm just going to write here. We have a squared plus b squared equals c squared. And we want to give it to the nearest 10th, so obviously it's probably going to be a decimal. All right, I know my a is 2, so I have 2 squared plus b squared equals 7 squared. Okay? 2 squared, we all agree, is 4. We don't know what b squared is yet. Plus b squared. B there or b squared? Sorry. Equals 7 times 7. I know a bunch of you know this. 49. Now, I want to get the b squared by itself, and then I want to get the square root of it. So I am going to subtract 4 from both sides. So I get b squared equal 45. And you can just do, if you want, the square root of 45. Take the square root, take the square root, and hang on, I'll be right back with that square root. Okay, so I hope you did it on your calculator, but the square root of 45 is approximately 6.7082, and they want it to the nearest tenth, so it's 6.7. So she's approximately 6.7 feet away from that bar. Okay? Not me. I don't know if any of you guys would be brave enough to do that. Some of you would. And some of y'all wouldn't wear a helmet either. Right? And here's their solution. And they got the same thing. And now, when I'm back, I'll show you how to do it in the calculator in all one calculation. But we've done that before. Okay, angle bisectors. What is an angle bisector? Bisector tells us to cut, it cuts something into two congruent equal halves. So an angle bisector cuts an angle into two equal halves. Okay, similar to a perpendicular bisector, an angle bisector is a ray that divides an angle into two equal halves. Okay, there are several important concepts associated with angle bisectors. Okay. If a point is on the bisector of an angle, then that point is the same distance from each side of the angle. Usually the lines to connect are drawn perpendicular to the sides of the angle, but not always. But 99.9% of the time. And if you notice right here, they did. All right. So since this is the angle bisector, this is the angle bisector of this angle, points A and B are equally distant here. These guys are perpendicular. If you notice, we're going to have two congruent triangles again. Okay? If a point is on the bisector of an angle, then the point is the same distance from the sides of that angle. So basically, any point on this angle bisector is going to be equally distant from B and C, from the ends. Okay? Any point. Okay? We'll use that more later. Okay, angle bisector theorem. Converse, if a point in the interior of an angle, now ignore these other lines, we're just looking at this angle. If a point on the interior of an angle is the same distance from that angle's sides, then it is on the perpendicular bisector. So point D is on the perpendicular bisector because it happens to be equally distant from B and C. Okay? You're not going to use that a ton. All right. I'm going to pause, and we're going to come back in a couple of seconds, and we're going to prove this. We're going to figure out this example. Okay, take a look at what we have here. What is the measure of angle MNP? I'm going to trace it for you. MNP. It's this angle here, the bigger angle. Okay, and explain how you know. Well, what do we know? Since it is equally distant from, since the sides are equally distant, M and P are equally distant from line M, okay, and they're perpendicular to these sides, okay, so if you remember, we're going to have two congruent triangles, so therefore, this is the angle bisector, and R is the angle bisector, so since it's the angle bisector, if this one's 47, this one's 47, put it all together, and 47 times 2 is 94, correct? Let's see what that says. The measure of MNP is 94. How do you know? Since point R is equally distant from the sides of MNP, which we know from the diagram, it's an angle on the bisector of MNP. That means MNR is congruent to PNR. Since MNR is 47, 47 times 2, 94. We good? Okay, we're good. I'm going to stop here, and I'm going to continue in another video, okay?